All right, thank you for tuning in again. Today we want to examine what we refer to as intersecting chords. Today we're looking at what we call intersecting chords. Now, from the word intersecting chords, you will understand what that is saying. Now, this is a circle with a center. A line that is drawn from a point of the circumference to another point of the circumference without passing through the center is called a chord. So if I have this chord and I label this chord as A, B, and I have another chord this way that I want to label as C and D. Now these two chords meet at a point. Let's say meet at point P. Now, therefore, what does the rule of this intersecting chords says? Now, the intersecting chord is the four lines are being used in determining the value of the intersecting chord. And if you look at the chord AB, makes up of two things, which are the two things that makes up of the AB are AP and PB. We take the products. Must be equal to the second chord is CD, which is formed by CP and PD. This is what we refer to as the rule of intersecting chords. So take notes that in determining intersecting chord, as soon as you have the chord, this is the first chord, this is the second chord meeting at this point. So for chord AB now is divided into two, which is APPB, and that's what you're seeing here. You take the product, you go to the second chord CD, which is divided into two as well, which is CP and PD, and the two must be equal, and that satisfies the property of intersecting chords. Let's see a question that will really help us to understand better what we are trying to explain. Okay, so let's get a question very urgently. 1 second, please. Okay, so looking at this question now, we want to find the values of x. So let us see the first question there. Now the first question, let's label here as point A. Let's say this is point B. Let's say this is point E, and let's say this is point F. So looking at the first chord, divided into two, 6 and 6, so I can say 6 times 6 is equal to what of the second chord? This is the second chord, which is divided into 2 as well, which is what? 3 and x. So you say 3 times x. And that will give you 36 is equal to 3x over 3 over 3. 3 cancels out 3, and x is what? 12. So by the time I put 12, but by the time I put 12 here, the value of 3 times 12 will be the same thing as the value of 6 times 6. Good. Now let's look at the second question we have. Now the second question also, this is a chord which is x times 10, and that is equal to the second chord, which is this 6 and 8, which is 6 times 8, and that will produce one fantastic result. X times 10 is 10x, is equals to 6 times 8 is 48. So over 10 over 10, 10 over 10, so x is equals to what? 4.8. And that is how you do intersecting chord. It's as easy as that. Now let's look at the second case study. Now let's call this study 1. Now let's look at what the second study of intersecting chord tells us. Okay, so let's say study 2. And in this case, we have a circle with a center. You have an extended chord. You have another extended chord meeting at point P. So this is called AB. This is called CD. So the rule of the intersecting chord here, don't forget that the chords intersect at an external point. So that means the relationship is the external. So if you take the first chord, the first one meets at P, which is AP, times the external part, which is BP, must be equal to the total, which is what? CP times the external, which is DP. And this is the rule here. So don't forget the rule when it is an external, when they are meeting at an external point is the total length times the external part must be equal to the total length times the external part. Let's take another set of questions very quickly. And this would be a very fantastic question to really deal with. Okay. 1 second. Okay. So let's look at the CP is 27. So let's label first. The whole of CP is 27. DP is 10. PB is 12. The first question says we should find AP. So let's go to the first chord. It's always total. That's the total, which is AP times external is equal to the second total, CP times external. And what's our AP? We don't know. So let's say that is let's say AP is X. So we have X times 12 is equal to CP is what? 27 times DP is what? 10. And that gives us 12x is equals to 270 over 12 over 12. 12 cancels out 12, and x is equals to 2, that's 24. In 30, that's another 2.5 centimeters. Okay, so don't forget, let me recap. In doing this, it's usually the external it's usually the total times the external, the total times the external. Now let's try the B part of the question and let's see what results that we want to produce. B says we should find AB. So we're looking for this. So that's really easy. So AB plus 12 will be equals to X. And AB plus 12 is equal to 22.5. So AB will be 22.5 minus 12. AB is then equal to 10.5 cm. Great. Now that is the first two studies. Now let's look at the third study. This is the third study that has to do with the tangent. When it has something to do with the tangent, what do we do? That's really easy as well. So when I have this, I have the center, and I have something like this, then something like this. Now don't mind my diagram. This is actually the tangent. So let's take this as point P, Q, A, B. So in this case, when you have a question like this, now it is still like external, but the difference between study 3 and study 2, I'm going to show you now, is that in the case of study 2, you have it like this and a chord that is being extended. But in this case, this is a chord that is being extended and a tangent. That is what you have. So it is really important you seriously take cognizance of that. Now I'm going to show you something very quickly so that you can clearly understand what I am trying to point out to you. So you can see something like this. So in this case, because it is a tangent, what you do is you still follow the process. Total AQ times the external, which is BQ, will now be, because this is a tangent and it's not a chord that has been extended, you multiply the tangent by itself. So that becomes PQ times PQ. So which is AQ times BQ is equals to PQ squared. So don't forget, when it is a tangent, you multiply the tangent by itself while you take the total times the external part of the chord. Okay, so let's see a fantastic example that will aid our understanding better. I hope I get one. Okay, great, I got one. So let's look at this beautiful question. Okay, so looking at this, so we take the rule, we take the total as usual, which is 16 times the external, which is 9, equals to, since this is a tangent, so the value of the tangent is x by itself. 16 times 9 will give 144. X times x will give x squared. And if x squared is 144, how do I get my x? I'll take the square root of 144, and that makes my x to be 12. And this is the concept of intersecting chords. We take it again. When the chords are inside the circle, you divide it into two, multiply by themselves, A, P, P, B. When it is an external, from an external point, the total times the external. And when it is an external and a tangent, you multiply the tangent by itself. And that is that. I hope this helps, and I hope you get to understand this better. Thank you very much.